derivative of this, then locate the relative maxes and relative mins. Okay, so for this part, relative maxes and relative mins, I know I'm going to test around the critical numbers if I want to do first derivative test, or I would test the actual critical numbers in the second derivative test, but I do not want to find the second derivative here. For the first derivative, you've got some choices. If you want to algebraically multiply all this stuff together, just make sure that if you do that, x minus 2 squared means x minus 2 times an x minus 2. It's not x squared minus 4. You actually have to distribute all that. If you don't want to do that algebra first, then you're going to have to do the product rule, which is what I will do. So product rule, take the derivative of the first part, which would be 1, times the second part left alone, plus the derivative of the second part. Consider chain rule, but there is no chain rule, with the first part left alone. So find the derivative of this. If that was an FRQ question, you're welcome to stop there. But I need to know critical numbers so that I can answer the second half of this question. So critical numbers are where this is going to be undefined. This is not going to be undefined anywhere because we don't have any x's in the denominator, or where it equals 0. So what I notice, and this is kind of like one of those practice FRQs we did a week or two ago, this term and this term have a GCF. They both have an x minus 2. So I can factor that out. X minus 2 times x minus 2 gives me x minus 2 squared. And then x minus 2 times 2x plus 4, or 2x plus 8, gives me that. So GCF. Combine some like terms in here. This equals 0 at 2. And this equals 0 at negative 2. So this question, notice it didn't say anything about critical numbers, but I know critical numbers are the places that this graph might be changing direction, so this is where I want to test. So again, now it just kind of depends on if you prefer first derivative test or second derivative test. If you prefer second derivative test, you need to find the second derivative. I'm not interested in doing that, although I guess it wouldn't be too bad. First derivative test, you're going to test numbers around the critical numbers. So maybe try 0. We'd get negative times a positive, which is negative. Try something out here. This would be a positive times a positive, which is positive. And try something over here. Bless you. This would be negative times a negative, which would be positive. That line chart helps me see my answers pretty clearly. It looks like there's a relative max at x equals negative 2 and a relative min at x equals positive 2. Now I don't like the vagueness of this. When it says locate them, to me this is probably good enough, saying where the x values are. But if this was a multiple choice question and the choices were points instead, you need to make sure that you plug these values into the function, not into the derivative. If I plugged in 2 here, I would get 6 times 0. Oh. Wait, so that would be 0, so that's not a problem. Plug in negative 2 here. This would be 2 times negative 4 squared, which would be 16, so 32. So if you needed a point, make sure you plug those x values into the function. I'd say the hardest part about that one was just getting the derivative and finding the critical numbers. But this has been not an easy thing, but certainly a pretty common theme. If you need to solve something that looks like this, you need to be suspicious and looking for GCFs. If it has a GCF and you can pull it out front, it usually makes it pretty manageable after that. Okay, anything more specific about 7 for anybody?